Hello, my name is Christina Wetzel, and this is Lab 3, Magnetic Field of a Bar Magnet. This lab report contains 4 major sections: the introduction to the lab, the data and calculations, the computer calculations, and the conclusions. First, in the introduction, I will outline the purpose, results, and physics principles relative to this lab. Second, in the data and calculation section, I will go over my collected data and observations and go through my calculation of the value of mu. Third, in the computer calculation section, I will explain my code and generated model and how they relate to this experiment. Finally, in the conclusion section, I will analyze my results and answer some theoretical questions about the lab. The overall purpose of this lab was to both measure the distance dependence of a bar magnet's magnetic field and to measure the magnetic field at a 45-degree observation location, in order to compare it with the computer result for the same location. The computer will use values found in the beginning of the lab for its calculation. The physics principles used include first the Biot-Savart law for on-axis dipoles and its derivative. This helps us find the magnetic field given a distance and a magnetic dipole value, or mu. Second, the distance dependence equation is used, which allows us to determine n and mu from experimental measurements. The results for the lab are shown here. Shown here is the data collected from my experiment. I used the app Teslameter on my phone to measure magnetic field, and compensated for Earth's magnetic field by lining up my phone with Earth's field so that the x component was 0. I then varied the distance of the magnet away from my phone, which is the chart for that, which is shown on the very left, and recorded the magnetic field in order to obtain the graph on the right. Analysis of the graph equation shows, according to the equation on the very right, that my value of n was equal to about negative 2.87. Finally, I moved the phone at a 45-degree angle from the magnet, and the magnetic field measurements for that are shown at the very bottom. With these measurements, I compensated for Earth's magnetic field in the y direction by measuring that at the beginning and then subtracting it from the measurement at the end to get the final y measurement. I observed overall that when the magnet was very far away, the x component of the magnetic field was almost 0, and that the magnitude of the magnetic field increased as the magnet moved closer to the phone. The next step in this experiment was to calculate the value of mu for the computer calculation. Examining the graph equation, you can see that the natural log of k is equal to the y-intercept. Additionally, examining the distance dependence equation and the Biot-Savart law, you can see that, with a value of negative 3 for n, k is equal to mu naught over 4 pi times 2 mu. Solving for k and then setting these equations equal allows us to solve for mu, and gives us a value of 2.356 to use in the coding portion. These calculations are shown here. Shown here is the coding portion of this lab. I begin by defining constants, my value of mu, and creating a function to calculate the magnetic field of a dipole, which is based on the derivative of the Biot-Savart law shown at the beginning of this video. Then I created arrows to show the calculated magnetic field using this function at different locations on and off axis. Finally, I created an arrow to show the 45-degree angle magnetic field, and printed this value onto the bottom of my model for comparison with the experiment. Here is the model generated by my code, with 2 on-axis magnetic field values in orange, 4 perpendicular magnetic field values in blue, with half the magnitude of the orange values, and 1 45-degree magnetic field value shown in green, and printed at the bottom for reference to our non-computer calculations. My final results can be seen in the upper right corner here. Overall, my value of mu was close to negative 3, the value derived in the Biot-Savart law, and my y values were very similar in the final 45-degree magnetic field vectors measured both experimentally and electronically. My x values were slightly different, which may be due to external magnetic fields impacting the measurement. My value for mu was also in the range of acceptable answers given by RTA, so my overall results for this lab are reasonable. One question was, what if you hadn't oriented your experiment to compensate for magnetic north, and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? My answer to this question is that if the phone was not aligned with Earth's axis, Earth's magnetic field would have interfered with the data and skewed our x value due to the superposition principle of both Earth's field and the magnetic field. The second question was, what if we were to stick two identical magnets together end to end and run the experiment again? If we stuck two magnets together, I would expect the value of mu to double, and nearly double all of the measurements in the x-axis and in the y-axis for the 45-degree angle part, for the magnetic field. Overall, that's it for Lab 3. Thank you so much for watching.